All right, here we go.
Sweet.
Woke up in the morning, took my friends to Mexico. I knew all of the canyons and could tell them where to go. Cause I had seen them in a dream that seemed to last 2 weeks. And since my trip was 2 weeks long, I think that's pretty neat.
We are going south. So far south that no hablan inglés donde vamos. I'm Randy Marrett, and I'm a geology professor at UT. We're going to go to Mexico and see the Sierra Madre Oriental. And we're going to see cool stuff. Gigantic folds, carbonate rocks that only a carbonate sedimentologist could love, and me. And they're full of all kinds of little structures. It's the kind of place where 10 years after, actually over 10 years after starting to work there, I keep finding new things. And it's just like those little Chinese boxes where you open one and there's another one. So you open it, there's another one. It's this gigantic puzzle. This is called Cañón Escalera, which means the canyon of stairs. What would be the hanging wall, the rocks above here, were moving roughly in that direction relative to the bottom. So left slip, looking at the outcrop in that fashion, in 3D, mostly normal motion apparently. Of course, there's no reason yet to conclude that the fault formed when the rocks were in this orientation. If that same fault had formed before folding, namely if you just rotate everything around like that without altering any of the features of the fault, you decide that it would have been a reverse fault if it predated tilting of the beds during folding. So it's another good question about timing. So what is it? Is it a normal fault that formed at the end of folding, a reverse fault that formed before folding, or some structure that's contemporaneous with folding? What kind of things would help us decide? Today we've spent the entire day really at two large outcrops here in a single canyon, both of which are within 15-minute walk of where we're camped, meaning that we literally spend almost the entire day looking at rocks, making observations, figuring out what they mean, making inferences about the bigger scale picture on the basis of those observations, because I think that's what students learn the most from.
1.4.
Because I know a lot of you are still in the process of defining or at least refining what your research is going to be. And I would encourage people to think in a process-oriented mode. Again, I obviously encourage most people to have a significant field component to what they do. But the point isn't to figure out the geology in this little valley. The point is to figure out what you can learn from this little valley that may have importance that goes for thousands of kilometers or global in nature. They're so big that the truth is they're hard to appreciate at any particular point on the ground. The package of rocks that's affected by those gigantic folds is a pretty thick package, something like 2 or 3 kilometers thick, mostly of carbonate rocks. And each limb of the folds, by and large, makes its own mountain range. Mountain range tops to the south, anticlinal axial trace going up the valley. Here's this second range back, syncline following the valley. Actually, the valley follows the syncline, right? Another mountain range. We're currently camped right in this canyon right there, in the midst of this range. When you go through the canyon, you come out into another valley, and that's the second anticlinal trace right here. So you get a chance to at least visualize what that would look like. And our first real opportunity to see much of the big folds will happen on our drive out of this canyon. One of the reasons that I'm a field geologist is I just love the road trip. I love to go new places, see new things. As a kid, I loved to travel and I loved to walk around outside. And fortunately, I found geology early enough in life to appreciate that it would represent a potential opportunity to combine doing that kind of stuff that, if I couldn't do it as part of my job, that's what I'd spend all my vacations doing, and integrating it and literally making that a significant portion of my job, namely my career, so that there's an intellectual path that goes right along with the geographic exploration and the cultural exploration. And in a nutshell, it's really nothing short of adventure. Adventure is the generality, but field geology is a great excuse for camping. It's a great excuse for drinking beer. It's a great excuse for spending quality time, a lot of time, with people that you like.
I like geology because this is our classroom, and I don't know, it seems real world, tangible.
It's something that involves a lot of math, especially if you want to use math for it, but geology is something that I think you understand qualitatively as well.
I like being able to work outside as much as possible. I like field work, and geology lies at the foundation of a lot of different sciences, so it's an important thing to understand. It's pretty cool.
Because you can play outside. It's fun. Rocks are cool.
I like geology because I like outdoors and field trips and nature in general, and hiking around and camping. And geology was a good way to do that.
To a great field trip, to good friends, to Halloween, Day of the Dead in Mexico, and good food.
Run, shake.
Now we have to go around
Oh yeah, oh yeah, na na.
I don't think I've had anything but beer, except the tequila shot. I don't think I've had anything.
Always a beer can for scale.
I like geology. After being on this trip, that's kind of a silly question.